Afternoon. Okay, so I'll spend the next about 45 minutes to talk about emerging the privacy-preserving technologies, which is a very important area in the data-driven economy. As Xiaofan introduced, I am, apart from being the director of NTC, I am also a professor of computer science and director of SCRIPS, which is the Strategic Center for Research in Privacy Preserving Technologies and Systems. So to start with, just a quick introductions about Scripps. Scripps is a multidisciplinary research center funded by our National Research Foundation, as well as our Infocom and Media Development Authority. Our mission is to look into or research into privacy-preserving technologies because it has a very strategic importance in protecting personal data in the digital economy. Basically, as you can see, nowadays, when we talk about the digital economies or data-driven economies, we talk about very often data analytics or AI. But whether we talk about analytics or AI or big data, most of the time what we're trying to do is to discover new knowledge, insight, as well as to enable machine learning. And we have seen a lot of internet services being offered on the internet. And each of these internet services, whether it's free or paid, they are bound to gather or acquire a lot of user data. And an additional advantage of all these internet services is that by aggregating all these user data, they're in a very strong position to perform big data analytics or machine learning. Now, with this in mind, we're also asking, but we are the users of those internet services. Would my personal data be used as part of this machine learning? And if it does, would it compromise my privacy? So now you get to a situation that on one hand, we encourage analytics or big data or AI because it's one of the important part of enabler of the digital economies. But on the other hand, we start to worry about privacy issues. As I mentioned earlier, we have seen a lot of this type of AI or machine learning being adopted almost in every part of our life. So we have seen the success of deep learning. And even when we talk about our smart nation or lots of smart cities architectures, we're also talking about cloud. Now, the use of the cloud is another area that enable the digital economy because given the characteristics of being scalable and borderless, so we can see a lot of internet services being provided through the cloud platform. And so it is all these cloud-based internet services that provide value-added functionalities to users, whether you talk about payment, whether you talk about just doing photo editing, or you talk about financial transactions. So all these cloud service provider, they, as I mentioned earlier, gather a lot of user data. And all this user data will enable them to do machine learning or deep learning. So all this together, on one hand, to the service provider, you can understand that they can make use of the data to improve their customer service. But on the other hand, you also will start to worry whether they will make use of the data for other purposes. And what are these purposes? Will they share the data with another parties? And maybe when I decide or when I choose to use this service, I am willing to give my personal data to this service provider. But will this service provider share my data with another service provider, which I have no idea at all? So all this will make the issue of privacy more severe. Now, as mentioned, with all these large amounts of personal data, especially if it involves biometrics, but nowadays, given the fact that a lot of people like to even upload their own personal photo from their social life, daily activities onto the onto such internet service. So all this personal data is bound to involve biometrics, as at least, for example, your facial data. So, and all this personal data, which has been collected for analytic and AI purposes, could potentially be shared, right, with other parties, as I mentioned earlier. Then we start to worry about people being able to aggregate all your personal data and compute a profile about yourself. For example, maybe you only use one cloud-based service provider to do your payment, and another one to put up your photo, like those type of Facebook, and yet another one to do your own work-related files. So each of them, you feel reasonably comfortable because they only have one aspect of your life. So you still don't feel overly intrusive. But if somehow at the back, all the service providers start to aggregate the data, and they may potentially put together a complete pictures about yourself. When I say pictures, not just about the photo pictures, but about your personal life. Now, this will be extremely uncomfortable. So that's why when we look at data itself, we think it's a good thing. It can make things a lot more convenient, can, as I mentioned, can enable machine learning, can help improve customer service. But if they are not controlled, and such data, if they are shared indiscriminately, then you start to worry about the privacy issue. Now, I used one example in this in this slide. About 3 years ago, I did a project to study the security and the design of the national ID systems of India, the Aadhaar. And the system contains hundreds of millions of people, their data, including their passport photo, their 10 fingerprints, their 2 iris, their mobile number, basically everything about the user. So if such a database is being leaked, that will be privacy disaster. So, but on the other hand, the value of such a database is that it can provide a very reliable means to authenticate use of any online services or digital services. So which means this database will directly or indirectly to interact with other online service provider. Like, for example, in the case of India, they make use of the national digital ID systems to support micropayment, or what they call a mini ATM. So that means this database will need to interact with other systems. And with people start to worry, will this database work with other service provider to start to construct a complete profile of every user? And also, this is only one part of the problem, that is the privacy concern. And on the other hand, will all the service provider be work together to, or so will this database be attacked or hacked that will lead to another cybersecurity disaster? So all this go back to the data privacy issue. That means all this personal data, which is captured by different internet service provider, have to be properly protected. No, but this is only the cybersecurity aspects of the data. But on the other hand, what we worry is that is the dilemma of the problem. That is, on one hand, we think it's good to share data because it can help improve customer service. It can help improve the performance of all the machine learning. But on the other hand, we worry about the data sharing. So because of that, one of the strategic research area is, would it be possible to protect the data and yet they can be shared to support analytics and machine learning? That means we encourage them to share data, but we don't want them to see the content of the data when they share. But if they don't see the content of the data, how do they perform analytics on the data? So this is basically the problem that we're trying to solve using these emerging technologies of privacy preserving techniques. Now, as I mentioned, it is not just about we worry or we want or we don't want. Currently, in most parts of the world, we start to see a lot of regulations that is putting more and more regulatory requirements on privacy protections. For example, the very famous one is the European Union, the GDPR, which is a very stringent general data protection regulations. In Singapore, we also have our PDPC or PDPA, which is another regulations on personal data protections. So all these regulations regarding personal privacy have to be addressed. So that means if you are an entrepreneur going to set up an internet service by leveraging on some of the latest technologies on AI, IoTs, 5Gs, or cloud. So it's not just about your business idea. You have to understand the regulatory requirements. And of course, the easiest is just after you address all the functional requirements by performing the machine learning, the business logic. And then you make sure you have the proper cybersecurity control, and you try not to share the data with any other parties. But one day you may eventually feel the need to share the data. And if such a need happens, then you have to look into all these privacy protection regulations. So this is the one I'm not going to read out, but this is basically an overview of the PDPA, the Personal Data Protection Act, the scope that is specified by the PDPA in Singapore. So it talks about how the organization should protect the data which is being collected and how or being used. And this data typically are personal data that involve data that uniquely identify the persons, like NRIC, passport number, email address, things like that, and other demographic data. So these are the type of data that are covered by the PDPA. So if you see, at least here, we talk about facial images, biometrics, like what I mentioned earlier, some of the digital ID systems, they make use of facial recognitions, fingerprint matchings, iris matching. So all this data if it's being captured by the digital ID systems, will then have to comply with the PDPA. And apart from in the Singapore context, apart from the PDPA, we also have other sector-specific legislation that will impact the data protection requirements. For example, in the banking sector with the Banking Act, which contains a number of banking secrecy provisions governing customer information obtained by the bank. And we also have the Telecom Act, which also governs the use of end-user service information, and the hospitals, the healthcare sector, and the government sector as well. So these are sector-specific legislations that require the organizations which capture the customer data to protect the data properly, according to the requirement spelled out in the Act. And there are other general legislations that is relevant to data protections, including the Computer Misuse Act, the Cybersecurity Act, the Spam Control, and electronic transactions. So that's why, from the regulatory angle, lots of things has been done. So that means if you want to be a technopreneur, going to make use of some of the latest internet technologies to build an online business, as I mentioned earlier, it will not be just about the business function itself. You also need to look at all the relevant laws and regulations that you have to comply with if you need to collect customer data. But nowadays, if you're entrepreneurs or if you're technopreneurs, you know one of the important part of the game is to do fundraising from investors. And usually the investors will value your company based on the number of users you have or based on the number of subscribers you have. And therefore, in order to attract investors, then you need to capture your customer data. And because of that, you need to start to worry about all these regulatory requirements in order to preserve the value of your online business when it comes to investment. And obviously, from some of the recent news about internet attack, breaching of personal data, you have seen how some big internet company could be in financial trouble just because of the leakage of personal data. And a related aspect is the data governance issue. At a large scale, all this massive data needs to consider more than just privacy, but also how to govern and utilize the data. So it's not just about protecting the data, but how to use them is another matter that need to be considered. And it's basically a quality control discipline for assessing, managing, using, improving, monitoring, maintaining, and protecting the data that's being collected by the service provider. So then we also need to look at all the laws and regulations that we mentioned earlier. But the challenge for the data owner is to strike a balance between the data utility versus the governance. And of course, as I mentioned earlier, if you just capture the data and you don't use it, then you don't have much problem. But you can't really create value from the data, apart from just telling the investor that you have lots of users. But if you really want to take advantage of the data through analytics or through machine learning to create a real value for the digital economy, then you need to make good use of the data. And when you make use of the data, then you have to look into the data governance issue. So now we come to the core part of this talk. Now, we've been talking about digital economy. We've been talking about with all these enabling technologies like IoT, sensors, 5G wireless network, cloud, which aggregate all the data, machine learning that analyze the data, big data analytics. So this basically make the digital economy happen. But then we start to worry about privacy issue. And when it comes to use of the data, we talk about the governance issue. But what technology can be applied to solve the problem, or at least can be investigated to address the problem? So this is the purpose of the privacy preserving technique. And basically, this, in short form, the PP tech, is to look at ways to enable the data to be processed in protected form. In protected form means it could be encrypted. That means you want to analyze the data even when they are being encrypted. Or you want to use the data even when it is not really the same as the genuine copy. So of course, when you read the data from the database, you don't really tell people the genuine value. You tell some random value. Then of course, it is very private. You can preserve the privacy, but the data is useless because you can't be analyzing on some random data. And our common understanding is that you can also encrypt it, but you can't really make use of the encrypted data. So that's the objective of PP tech. That is find ways to encrypt the data, and yet you can make use of the data. So some of these areas that in our research center we are working very hard on include here the differential privacy, homomorphic encryption, secure multi-party computations, or searchable encryptions. Now I'm going to give an overview of each of these techniques. And basically, all these techniques is about protecting the data so that they can be analyzed, even when the person or the party who make use of the data cannot see the data. So the first technique that we talk about is the secure multi-party computation, or MPC. If you have not heard of this term, just imagine it as a kind of technique that allow, let's say, three parties to work together to compute a statistics without explicitly telling each other the value of the data. So what they do is they encrypt the data, then exchange the encrypted data. Then each of them will compute on the exchanged encrypted data. And this way, at the end, all of them will have the same value, but none of them will know the data of the other two parties. So MPC scheme help multiple parties correctly compute a function with private inputs with no further leakage than the output itself. So this diagram here illustrates a very simple understanding of the concept behind secure MPC. When I say simple mathematics, means about undergraduate first year mathematics. If you are not a STEM graduate, then just take it as a picture. And pictorially, how does it work? Now, if you look at the left side of the diagram, if I have three parties, each of the parties have one number, and it's about their salary. If these three parties decide to find out what is their average salary, but they don't want to tell others what is their salary. So one way is to make use of the MPC to share the encrypted value, and then they can, at the end, compute the average. So the right-hand side illustrates the way that they exchanged encrypted data. And at the end, they make use of the encrypted data that is being exchanged to compute the average. So fundamentally, MPC relies on the sharing of encrypted message among all the parties, which is configured in such a way that through the required analysis and calculations, the sensitive data is not shared between the parties or among the parties, but the correct end result can still be obtained. And with the use of MPC, of course, just now we talk about using MPC to calculate some statistics. Like we have built a system demo that allow multiple parties to calculate the average value in a secure way. That means without disclosing their own value, but several parties can work together to calculate the average. So of course, with the average, then we can calculate other statistics like standard deviation. And also with this calculation, we can basically also make use of it to do machine learning as well, because basically machine learning is all about calculating some mathematical function. And we have also built a demo systems that allow multiple parties to do a secure auction. That means how to compare the value that each of these parties submit, and yet without knowing the exact value, but we can see which one is the biggest. So that is the purpose of the secure auction. That is to find the party who give the biggest number, but still no one knows the actual number until the result is being determined. So this is what we call the secure auction, which can be used through the MPC. Now, of course, in this overview lecture, we only can have time to give you an idea about what can be done with the MPC. We are not going to have time to give you all the details about how this works and how to use the MPC to achieve secure auction. So with the concept of secure auction, then of course we can also use it for private share offering. So basically, it's to enable multiple parties to exchange a value, the secret value, and then determine, in this case, which value is the biggest. And the value, the largest value will be the winning prize, for example. So just now we talk about secure multi-party computations. Now we talk about differential privacy. Now the concept is very simple. If you're a computer scientist, if you want to read any of the research paper on differential privacy, you'll see tons of mathematics. But regardless of the mathematics, the concept is pretty simple. And in fact, the purpose of the mathematics that you can see from those research papers is to prove that this simple idea works. So what's this simple idea? First, you have the data. The data is being kept in the database, for example, which could be sensitive data, like your personal data, or your customer's private data. And when people inquire, make a query about the data in the database, if you just honestly, naively reply to the query, so after a while, the person who queried the database will be able to determine some personal data about a particular individual, as I will illustrate later on with some diagrams. So one way to address this problem is whenever someone queries the database, and instead of just returning the correct result, which is being retrieved from the database, you add some noise to it. And because of the noise, so the person who makes the query will not be able to determine the exact value of a particular individual by repeatedly making the queries, multiple queries. But of course, this intuitively work because, like I mentioned earlier, if people ask you, instead of telling the truth, you always add some random lies to it. Sometimes you tell lies, sometimes you don't tell lies. So then the guy who listens to you don't really know whether you're telling the truth or not. So will not be able to determine some or to infer some personal particulars about yourself. But then the question is, if you keep telling lies, you may as well don't tell people because it's useless. So on one hand, we want the data to be useful, but on the other hand, we want the noise to be controlled so that we have enough privacy protections. Now, I mentioned earlier, if you talk about differential privacy, you'll see a lot of mathematics. All this mathematics is about how to find the balance. The balance is about utility of the data and privacy of the data owner. So you add enough noise to make the data secure enough to protect the privacy. But the noise is not big enough to jeopardize the utility of the data. So the concept of differential privacy can be summarized by these definitions. Basically, it's the output over two neighboring data sets. Data set means the outcome or the retrieved result of a database query cannot be distinguished. So the data record in or out of the database cannot affect the output. So if this is satisfied, then the attacker cannot infer the user's information by observing the output. So the way to achieve this, as I mentioned earlier, is to hide the private information by adding noise. So every time you retrieve a result from the database, instead of just naively telling the exact value that you retrieve from the database, you add some noise. So using a simple example, if you are 24 years old, and if people ask you what's your age, instead of just telling people your age, 24, every time you add some noise to it. Sometimes you say 23, sometimes you say 25, depending on how you want to strike the balance between utility of the data and protection of your privacy. So as I said, then the privacy level can be controlled by adjusting the added noise. And of course, this limits the precision of the analysis due to the added noise. This diagram basically illustrates the concept of differential privacy. So when the user make a query to the database, the answer returned from the database will be added with a noise. So this, if you accumulate this noise, because the noise is random. So when the user receive this noisy data, it will make it more difficult. We won't say impossible, but at least make it more difficult for the users to continue to make queries and infer some personal particulars of people inside the database. So what could be these particulars? Now we show this example here. We have this database containing a number of users. Even if, let's say, we de-identify, anonymize the database, we remove all the names. But we have other fields like that, the job, the occupations, the gender, the age, and some medical conditions. So if the user keep querying the database, so by repeatedly querying the database, it will be able to pinpoint a particular person who you don't even need to know the name, but because you know the job or the occupations, the gender of the person, by querying it, you eventually will be able to infer that this person has this particular medical condition. So this is why differential privacy is important, because you cannot simply just identify or anonymize the data in the database. And so it sounds straightforward, but it also sounds not very useful. But in real world, differential privacy has been widely used by a lot of internet service providers for supporting privacy protection and yet statistical analysis. Now, for example, those internet browser you are using, the browser developer or the browser provider, they regularly pull statistics from your browser so that they can do some machine learning in order to see how to improve their service. But if they pull everything out from all the history from your browser, then you feel uncomfortable because it compromises your privacy. But on the other hand, they have the need, or you also want to participate in the effort of improving the service quality. I'm sure when you download a new browser, when you buy a new phone, when you run a new app, sometimes you see this message. Would you like to send us information about your software? This is only for the purpose of improving the software. This is only for the purpose of improving the software. So sometimes you feel it's good for everyone, so yes. But the question is, when you say yes, will it just download or pull out every behavior records about yourself from the software? So if this is the case, then you feel uncomfortable. So in order to encourage people to share this type of data with the browser provider or with the software provider, now they make use of differential privacy. So this is how differential privacy has been widely used in recent years by a lot of internet service providers. The other technique is the homomorphic encryption. Now, this technique basically is really about encryption, but this type of encryption have a special characteristics. That is, you can perform calculations on the encrypted data. Now, for example, ordinary or normal encryption algorithms, once you encrypt, it becomes useless. You can only use it when you decrypt. So if you have two numbers, 1 and 2, 1 after it's encrypted, it becomes some random number. 2 after it's encrypted, it becomes another random number. And you can't really do anything with that. But with homomorphic encryptions, it means that after you encrypt the 1 and you encrypt the 2, and this 2 random number, or which looks like a random number, which is the encrypted data, you can do an addition. You can add the 2 encrypted data, which of course becomes another seemingly random number. But if you can decrypt it, when you decrypt, you will see the value 3. Right? Whereas in other normal encryptions, you encrypt 1, you encrypt 2, you add the 2 encrypted data together, and then you decrypt it, it becomes another random number, another rubbish. So that is the purpose. That is, you can encrypt the data and then you can do computation on the encrypted data. Now, if this is possible, then of course, you'll be able to share the encrypted data to do machine learning. Because as I said, machine learning is just basically computation on the data. So this technique can be used in situations where an external party has capabilities that the data controller doesn't have. But this external party wish to provide the analytics as a service. And this party will not be able to see the data and yet can compute the data. So homomorphic encryption allows analysis to be performed on encrypted data without the information itself being readable. And this diagram illustrates this concept. So homomorphic encryption, as I mentioned, allows analysis to be performed on encrypted data without the information itself being readable. And the result of the analysis will also not be readable by anyone other than the intended parties. So in this case, you see the data in usual way. If A has the data, A will upload the data to the cloud or to the data processors. The cloud will perform whether it's machine learning or any calculations on it, and then return the result. So this way, when you use the data processor, or when you use the cloud, you basically give up your personal data. But if you encrypt it, then the cloud will not be able to do any calculation for you. But with the homomorphic encryption, you can perform homomorphic encryption on the data, and you upload the data to the cloud, which is the data processor, and the cloud can process the encrypted data and return it to the user. When the user decrypts it, it will see the result accordingly. So this is a mathematical way to illustrate the point. That is, you encrypt the data and you tell the cloud to calculate this, to compute this function on the encrypted data. And the cloud will use, because it's homomorphic encryptions, the cloud will perform the function calculation on the encrypted data. And the return is the encrypted value of the function. As if you remember earlier, we say you encrypt 1, you encrypt 2, then you add. Then it becomes the encrypted value of 1 and 2. That means it's the encrypted value of 3. So this is the computed value. And the result is the encrypted version of the computed value. So if the user can decrypt it, it will be able to see the computed result. So that means if you see this F as a machine learning, so then these are the encrypted personal data. So that means you encrypt the personal data and provide a machine learning function to the cloud. The cloud will use the encrypted personal data to do the machine learning. And the result is the encrypted result of the machine learning output. So in this case, the cloud server computes the function without performing the decryption. Whereas when the user eventually decrypt the result, will be able to see the output correctly. And we have done an example. That is, let's say we do a pattern recognitions and AI algorithms that recognize handwritten digits. Let's say we have these handwritten digits, and this digit is encrypted using homomorphic encryption. So basically, the output of this encryption is something that you don't know what it is. Then you send it. So this is the picture. This is not even a numeric value 8, it's just a picture. So you encrypt the pictures. Then you send it to the cloud. And the cloud is the one that performs the analytics to determine whether this what is the value of this handwritten image. So after this, the cloud, which perform the neural network recognitions, will determine this is the value 8. Now remember, this is the picture of handwritten digit 8. And this is the encrypt value of the number 8. So remember the difference. Here is the handwritten image of the digit 8. And here is the encrypted value of the number 8. Okay? And then the number or the result of the recognitions by the neural network is then sent back to the user. The user will then decrypt it and see the result. So of course, this is a very simple examples that talk about how to do recognitions of image. But of course, if more work is being done, eventually we're aiming to see a situation that this is not just a simple digit. This can be a fingerprint, or this could be a face image. And the face image can be encrypted. And there is a big neural network which can work on the encrypted facial image to come up with the output of the recognitions and then return to the user. And in the whole process, the cloud will not see the image of the person and will not see the outcome of the image recognition. Lastly, we talk about another technique, searchable encryptions. I'm especially interested in these searchable encryptions because, as we said, a lot of things are moved to the cloud. And to us, if your data is not important, not sensitive, you just use it as a dustbin, things that you don't want to delete, but you don't really care. So I know a lot of people, they just upload it to the cloud and most likely just forgot about it, because just to save their own storage space. But if you really want to use it, for example, if you talk about this digital economy, people talk about cloud native architectures or service-oriented architectures. So you move your data to the cloud and then you offer it as a service to another applications and so on. That means a lot of cloud applications are interconnected together to form a more complex online applications. So in this case, your data will need to be stored in the cloud. But in this case, if your data is sensitive, you want to encrypt it. But if you encrypt it, you can't really use the data. We take the most simple example. One simple thing is we upload, we did some other projects to do intelligent retrieval, document retrieval. So we have millions of documents that need to store in the cloud. So we allow users to do retrieval of the document by doing a search. So if your document is sensitive, then you may not want to use the cloud. But if you don't use the cloud, your own storage may not be big enough for millions of documents, which could be terabytes of data. But if you encrypt the document, you won't be able to search for the document because it's encrypted. We know this is the typical problem of database encryptions, because if you encrypt, you cannot search. If you don't encrypt, it is not secure. So it's a balance between security and utility again. So the purpose of searchable encryption is to enable the people to encrypt the document, encrypt the files, encrypt the data, and yet they are able to search the document. So in this case, the participants could be a client who wants to store an encrypted repository of documents on a server. And the server cannot access the encrypted data, but need to be able to respond to search queries. In terms of functionality, the client sends the encrypted search queries to the server. And the server returns the matching encrypted documents without knowing the content of the document. So basically, the server which performed the search doesn't know the document and doesn't even know the query, but is able to perform the search. So this is what we call the searchable encryption. So the server, as I mentioned, it returns the matching encrypted document, but should not learn any information about the document content or even the search query or the search result, as illustrated in this diagram. So all the documents are encrypted and stored. Now, this has the advantage that even if you say, I trust the cloud, even if you say it's a private cloud, it's my own company cloud, so it's in the cloud. But being a cloud, that means it's publicly accessible. At least the interface is accessible over the web. And we also know, we all know about the security issues of web applications. So if your data is accessible on the web, even though you may have very stringent access control to the data, you may worry about hacking. And if one day the cloud storage is being hacked, then you start to worry about data leakage. So if you encrypt the data before it's uploaded to the cloud, so at least on one hand, you can rely on the access control of the cloud service provider, and on the other hand, even if the cloud security is being compromised, but at least you know your data is encrypted. So this gives you another layer of security protections. So this will be very important for applications, for internet or cloud-based applications that needs to deal with highly sensitive data, especially personal data that involve those items that the PDPA is concerned about. So the framework is illustrated in this diagram. So the SSE is a family of encryption schemes that aim to support efficient search on ciphertext. And just now we talk about homomorphic encryption. We talk about multi-party computations. And as long as there is encryption, there is computing overhead. It's slow. Just give you some idea. Among these few PP tag, homomorphic encryption is very slow. It's because it's very slow. That's why it is still not widely used yet. Otherwise, if it's so powerful, so useful, and so efficient, everyone would be using it. But unfortunately, this is an area that we can make use of it in certain situations. But it is not to the extent like other encryptions, like this, those you use in your internet banking, that can be used regardless of the application scenario. So because of that, we need to explore different types of PP tag so that we can determine, depending on the nature of the application, what is the most suitable technique that can provide the security protections, the privacy protection, and yet is efficient enough to be practical. So searchable encryption is more efficient than homomorphic encryptions and multi-party computation. But of course, in terms of security, it is not at the same level of security compared to the other two. But we do cybersecurity, we know that in real world, no security techniques are 100% secure. And that's why in cybersecurity, we have this concept called risk-based security strategy. We look at the nature of the problem. We look at the sensitivity of the data. We look at the performance or the time delay that we can afford. Then based on the risk that we are willing to take, we choose the best combination technique. So even if you talk about your internet banking, your mobile banking, your e-government services, they are all based on risk-based security strategy, because basically all the encryption techniques that is being used nowadays, they are all in theory breakable. So that is the nature of the SSE, to give you an idea about the performance and the security strength. So that's why we need a very deep understanding of the various techniques, so that you know how to strike the balance, how to make use of which technique in what situations. So some use case as illustrated here. So again, this type of techniques has some early success. There are some applications that is being designed by making use of this technique. But as I said earlier, all these new techniques, emerging techniques, they have their own value for being in existence, but they have their own limitations, and that's why they are still emerging. They are not like those public key crypto systems that was invented almost 40 years ago that can be widely used. So, but even you look at public key crypto systems, it's been around for many years before they can be used widely, because people need time to have a deeper understanding of their strength, their weakness, and their limitations. Now we are at the same situation with the PP tech, and that's why we consider this a strategic research area, because we need to build more capabilities in better understand the strength and weakness and limitations. And then we need to work with real-world application developers to adopt or to introduce different types of PP techs for solving real-world problems. So to summarize, in this talk, we first introduced the concept of AI analytics, neural network trainings for the enabling the digital economies. And then we talk about the privacy issues, the governance, the data governance issues. Then we start to talk about some of the privacy preserving techniques that are of strategic value for enabling the digital economy, because with the use of PP tech, user will be able to share data. When they can share data, they will have more data. When they have more data, they will be able to drive the performance of the AI techniques or the AI or the analytic techniques. So with this, we basically in our research center, we focus on 4 important PP techniques that we believe is of great value that can be used for solving some of the real world problems. They are the secure multi-party computations, differential privacy, homomorphic encryptions, and searchable encryptions. So with this, I basically just finished my 1 hour, and I may not have lots of time for questions, but if there's any, I will be happy to answer. And if not, you can send email to this email address. I will be happy to discuss with you. And if you have any ideas or technopreneurship ideas to do any of the internet services as part of the digital economy, and you worry about the privacy issues, we'll also be happy to discuss with you and work with you. Thank you.
Thanks, Prof Lam. Hello, everybody. Do we have any questions? Just now I have got message from some of the participants. Yeah, you would like to check with Prof Lam if he can share the slides or something. I believe you have a lot of questions, so this is a very good opportunity to talk to himself in person.
Okay,
Oh,
I'm happy
mute.
to share the slide. I will provide the slide to Xiaofan. Then you can ask the slide from her.
Yeah, thanks.
Yeah. And as usual, I've been teaching for more than 30 years. I know people usually don't ask questions during the lecture or talk, but like to send me email after that. So this is the email address here.
Yeah. Okay. Yeah, feel free to if you are shy, don't want to speak, or you also can leave the message at the chat board.
Okay.
Yeah, you can unmute your mic and then ask questions. I know this is a very special area. For me, it's a dummy in this part. I think, but a lot of people here, you have a lot of a lot of you will have an IT background. Maybe you can ask more valuable questions.
Hello.
Yeah, I have a question here.
My question is, how do we know the service provider in the internet service provider provides or implement any privacy preserving technology to protect users' data? How do we know whether they actually implement the privacy preserving technology?
To be honest, you don't know, and that's why it usually would depends on their own disclosure. So just now we mentioned some of these case studies. Is in fact they disclose that we look into the details, because once they disclose, there will be some public documentations. But on the other hand, that's why we need to rely on those regulators. They do the enforcement of the personal data protections. But just as an end user, it is very difficult for you to see whether they're doing it. For example, unless you have you encrypt the data before you upload, then you explicitly know this. But if you just a layman user, you just run the app and take a photo of yourself and upload the photo. You don't even know what's going on after you upload the photo. So, in short, actually as an end user, you won't know, and that's why regulations as well as the technology play an important part.
Okay, one more question. So now we do not know. So let's say the service provider claim that they implement the privacy preserving technology. Okay, then say at cloud our data are now all encrypted. Let's say that is the situation. And then is there any technology or is there any mechanism that that help the user to know whether or not the encrypted data is now being attempted to be how should I say
I know what you mean. I know what you mean. That means you encrypt the data, and then whether the user knows that the data is being used.
No. Whether someone, whether it's third party or any other users trying to decrypt the data or try to understand the data. Is there any technology where we can detect that if that happens?
Unfortunately, no, because the data, once it's out of your hands, you don't know what people does. The only thing you can do is to encrypt it before you send out. So, but of course, whether people can make sense out of the encrypted data is a separate thing. It's the cryptanalysis that we're talking about. So that's why this PP tag is important, because if you use secure MPC, or you use searchable encryptions, or you use homomorphic encryptions, or use differential privacy, you protect the data before you upload it. But after you upload, whether people manipulate your protected data, there's nothing you can do.
Hello.
Yep.
My name is David. I was just wondering, Dr. Lam, you must have heard that there's concerns that Zoom is accessing a lot of private information. Do you have a comment on that?
I think technically, if you use their platform, of course, they can access all your data. This is not just specific to Zoom. You use WeChat, you use WhatsApp, you use Skype, you use all these things, or use Gmail. The system provider, the fact that they provide the service for free is that they want to derive some value from the use of the service. That means when people start to use, they will have to upload the data. Or basically when you exchange, you need to upload at least through the server. Then the server will be able to analyze. But of course, what do they analyze? You don't know. And also the intention of the analysis, you also don't know. So of course, there are lots of speculations, but I don't want to discuss the speculations, but at least technically, yes. And this is not just specific to Zoom, and it can happen to all the internet service provider as well.
Okay, thank you. Just one other question. I didn't quite follow your presentation about adding noise to the information. If noise is added to the information, I don't understand how you can, the person that's going to use the information, how can they determine what is accurate and what is not?
Because we usually use it to do statistics. We don't need, the fact that we want to protect privacy is because we don't want to disclose information specific to one particular person. So if we are talking about statistics, and let's say you make a number of queries, and in order to do the statistics, and at the end you will know that the noise is about, let's say 5% distortion, then you just adjust your result by this margin. So that will help compensate for the noise. So this is about how it works. But of course, as I mentioned earlier, a lot of those mathematical analysis in this area is about what type of noise will give you the privacy and how much noise will make it secure enough and yet still useful. So, and it's a well-known fact that if you add more noise, it's less useful. And if you look at some of the disclosed informations about differential privacy by those internet giants or the mobile phone giants, they really talk about their use of differential privacy for protecting the data when people upload their behavior data to their server. And if you are in this area and you understand the description of their differential privacy, you'll realize that the protection level is pretty low. And they focus more on being able to analyze the data rather than the privacy. So that's why sometimes it's important to have at least the awareness of the differential privacy, at least what type of level of noise will give you reasonable protections. But also because of that, if you look at some of the disclosed informations about some of the internet giants, the disclosed level of differential privacy is pretty low protection. Okay.
So I presume that the posters that when they do a poll on before elections and that's the process they go through, right?
Okay, that it is not about this type. It's more about statistics, because you talk about the polling of the or the voting. It will be, if you look at our example earlier, probably those multi-party computations or the homomorphic encryption is more suitable. That is, let's say you determine who to vote for, you write down the vote, then you encrypt it, then you upload to the server, and yet the server will be able to do the recognitions of what you wrote and do the comparison. Comparison means how many votes are voting, how many people are voting for the same value. So so again, that's what I said earlier. If we want to apply all this PP tech into solving real world problems, we need to look at the nature of the problem, and then we need to determine which technique is more suitable for that particular problem. So to get back to your point, so if you talk about polling, and I don't think differential privacy is a suitable means.
Thank you.
Professor Lam.
Yes.
Yes, this is Huafei. Thank you. Great talk. So my question is, how is the computational complexity of the best implementation of fully homomorphic encryption so far compared with the as a standard L-gamma encryption scheme? Thank you, Professor.
Okay. When we say best, you talk about security, you talk about the number of bits, you talk about the time, is going to be a long analysis. But so far, the implementations that we have done for this neural network, we can do it in sub-seconds to do for the homomorphic encryptions. But we also have one that, according to our analysis, will take hundreds of seconds. So, but for further details, in fact, we are having another workshop by jointly organized between NTC and Scripps on further details on all this PP text. So probably you can participate in that one that gives you a lot more details. Thank you.
Thank you, Professor.
Hi, Prof Lam. I'm
Yes.
Francis here. Okay, just now you mentioned that for technology company that gather a lot of user information, right? So you have to be aware of the security side of things. But most of the, let's say, mobile app today, they are international basis. So which country or standard should you apply to? If you apply to the lowest country standard, then actually no problem lah. But you want to stick to the highest country, then I think a lot of them will fail, right?
Okay. It is not about what we ask for. For those internet giants, they are multinational. They will have to comply with the respective laws and regulations. Some countries will say, if you want to serve my citizens or my populations, you need a local data center. The data about my citizens can never leave my border. So that's why if in this situation, that is straightforward, then you store the data in that particular jurisdictions and you apply all the relevant laws and regulations according to that particular country. But if the country is not as advanced, doesn't have all these regulations about storing data overseas, then it's up to the organizations to decide. And of course, businessmen being businessmen, they will look for, if there's no regulations, they will only look for the minimum so that they can, because as I said earlier, whatever encryption you apply is cost. It's slower, at least. When it's slower, that means you need a more powerful server. And when you need a more powerful server, that at least it means more expensive infrastructure.
I think when you mentioned that internet giant, we understand, right? But most of the apps today are not operated by international giants, right? So on one hand, they should bother. On the other hand, why bother?
Yeah, so then the next thing to look at is, let's say I also build an app. And the app was built by my startup. And my startup is registered, incorporated in Singapore. Then of course we follow Singapore law.
Okay, last question.
Yeah.
On one hand, I believe in, let's say even ASEAN, Singapore is most concerned about privacy and stuff like that, right? But on the other hand, let's say the medical records being leaked, it's just a small little slap on the hand. Say, hey, don't do it again. How the I mean the money is nothing, right? So is it really say one thing, do one thing type of scenario in your opinion?
You talk about the medical records.
Yeah.
I think in this case is from the angle of the service provider, it's a confidence issue, because if it's medical records, and usually medical data are heavily regulated, so it's not really, doesn't matter. And in a lot of countries, health data are heavily regulated. And also, why would hackers want to hack into medical records? For a very simple reason, they can sell to insurance company. So insurance company is most interested in health records because they can adjust the insurance premium if they know certain persons have some pre-existing illness. So, so going back to your point, I don't know whether I got your point correctly. So we look at the approach, and of course, if the company doesn't really care, then it's just really a matter of complying with the regulations. And then it depends on how strict the regulators enforce the regulations. Now we start to see, if, for example, well, Singapore, the PDPA has been around for a few years. You also have seen how they hand down fine to organizations that compromise personal data of the customers. And the latest I'm aware of is, let's say, Thailand. Thailand's and that the PDPA in Thailand was effective since last week. So we'll see how strict they are.
Oh, I mean, sorry, I don't think you answered correctly, but more of Singapore is more advanced in regulation, but the penalty is so low that.
Oh, okay, yeah. Okay. The penalty is so low. It is a issue with the lawmaking. I don't think I am in a position to comment. Many years ago, actually 20 years ago, or 25 years ago, I wrote a research paper on cybersecurity. So my recommendation at the end is security is not just about protecting the data, but or protecting the system. We need to have a cost penalty to the attacker. And the paper was rejected because the reviewer says these are political questions you should not discuss.
Okay, we take it offline. Thanks, Bob.
Okay. Right. Anything else? Any other questions?
Thank you, Prof.
Yes.
Do you know that is there a standard for differential privacy? Like, what's the standard for the privacy parameter epsilon? Like, let's say 10 or 1. Is there an international standard if you want to deploy this kind of application?
There's some recommended value, like those 1 to 0.1. And certainly 10. Certainly not 10. So there's some recommended values. So I mean, if people are interested in specific areas, we can have further talk on different types of techniques. Yeah, but there's some recommended value. I don't think it's I don't think it's an international standard at this point.
Okay, thank you. Another question is, we know there's quite a few real-world deployment or implementation of differential privacy, but how about MPC, multi-party computation and homomorphic encryption? Is there any real-world deployment, implementation, or business solution using these two techniques?
There are real-world applications of MPC and in other countries in Europe. And homomorphic encryptions, in homomorphic encryption, we have this thing called fully homomorphic. or just homomorphic, or partially homomorphic. So for fully homomorphic, because it tends to be slower, so I'm sure there are some applications, but it's not as well known as as differential privacy.
Okay, thank you.
Okay, thanks. Do we have more questions?
I saw
Okay.
one question: will quantum computing help to meet people? Will quantum computing help to make PPTech more practical? My view is it will not. First thing, quantum computing itself at this point is still not practical. So a not impractical thing will not make something more practical. Okay, so I'll pass the time back to Xiaofan. Thank you.
Okay, thanks everyone for your attendance, and thanks Prof Lam for your insight for sharing. Yeah, I think the purpose of this talk is, of course, highlight the importance of privacy preservation. Another thing is also, yeah, we are going to launch a program on this, so you can find more answers of your questions in this program. I just share a bit of this. Yeah, this is our program to be launched soon, which is on 15th and 16th of June. Since these few days, I think most of us will still study or work from home. Yeah, you can spare a few days time to join us. And also this program has been subsidized by government by 90%. So this is our advertisement. So feel free to join us. So, okay, that's all call it a day because I think thanks for your time to join us. I think after this, we will share more of the talks that are relevant to your interest. Yeah, thanks for your time and join us this afternoon.
Okay, thank you. Bye-bye. Have a good evening. Bye-bye.
Thank you.
Bye.
Thank you. Prof Lam.
Thank you.
Okay, bye-bye.